Hi, welcome to lesson number 3 in this tutorial series on practical electronics design. In our previous lecture, we saw the basic electronics quantities. We learned about the voltage, the current, the resistance, and how they are applicable in our electronics design. Today, we'll be moving further to component identification. We'll be introducing us to component identification and their symbols, because very soon we'll be working with electronics circuits, and in the circuit what you'll be seeing are the electronic symbols. And so when you see a symbol, you know, okay, this is the component we are talking about. And that is what we'll be doing today: electronic component and tools identification. The first component we'll be talking about is the resistor. The resistor primarily is used to oppose the flow of current. And so this is the image of the resistor. We have about 6 resistors here. It has just 2 terminals, no polarity, no positive terminal or negative terminal. You can connect them whichever way. So this is the resistor. The symbol of the resistor is this. So anytime you see this symbol in your circuit, you know it is a resistor. We have several kinds of resistor. This is called a fixed resistor. We have variable resistors, we have others, but for now this is what we need. As we progress in this course, I'll be introducing us to other kinds of resistors. The other component is the capacitor. A capacitor primarily is used as a storage device. It's used to store electric charge for a very short period of time. It can also be used for other functions like filtering, decoupling, coupling, and so on and so forth. But we have to also understand that there are various kinds of capacitors. We have the polarized capacitors and the non-polarized capacitors. The polarized capacitors are those that have positive and negative terminals, but the non-polarized capacitors don't have polarity, no positive, no negative terminals. This first one here and the last one here are known as electrolytic capacitors. They are polarized capacitors. They have terminals that they are very useful in storing electric charges, and they are used as filters. These other ones here are ceramic capacitors. They are non-polarized. They are used for coupling and decoupling purposes in electric circuits. The next component is the inductor. The inductor is just a piece of wire wound into a coil. So when you take a piece of wire, you wind it into coils. That's just an inductor. It has similar function as the inductor, but the operation is different. It also stores electric charge, but it stores it in a magnetic field. Unlike the capacitor that stores electric charge in an electric field, the inductor also stores electric charge in a magnetic field. They are very useful in FM transmitters, the design of antennas, in boost converters, and some other very important designs, as we will see later on. Another component that we'll be introducing us to today is the diode. The diode is the primary or the simplest form of a semiconductor. A semiconductor device is a device that at some conditions it works as a conductor, and at some other conditions it works as an insulator. A conductor is any device that allows current, electric current or heat to flow through it. Example is a metal. Your wire is a conductor. But insulators are devices that don't allow electric current or heat to flow through them. Example: plastic, rubber, and other objects that are not metallic, that don't conduct heat or electricity. Those are insulators. So this diode has a very good characteristics. It could work as an inductor at some conditions, and also as a conductor. Sorry, it could work as an insulator rather at some conditions, and also as a conductor at some conditions. And that's why it is known as a semiconductor device. It allows current to flow in only one direction. That's a very important characteristics of a diode. It allows current to flow in only one direction. It opposes current in the other direction. The symbol of a diode is this. It has 2 terminals, the anode and the cathode. The anode is the positive terminal, and the cathode is the negative terminal. This is the anode here, and this is the cathode. So as you progress in our course, I will show us how to really use the diode. The diode is very applicable in rectification circuits. Rectification is just a process of converting alternating current or voltage into a direct current or voltage. We are going to see that as we progress in this course. Another component is the light emitting diode. I must say that there are different kinds of diode. Aside from the diode I showed before, we have the photodiode, we have light emitting diode like this we are talking about. It's also a diode. It allows current to flow in one direction. It has two terminals, the positive, the anode and the cathode. But the only thing is that when current flows through this diode, it emits light. And you can see from the symbol, just the regular diode symbol, but two arrows showing the emitting of light. So that's just a light emitting diode. It's very applicable in Christmas lights, in fancy decoration lights. It's also applicable in modern days energy saving bulbs. It has replaced the old filament bulbs that we used to use. So LEDs are very applicable in our world today, and so we'll be using them in our designs as time goes on. So this is the symbol. Anytime you see this symbol, you know, in a circuit diagram, you know we are talking about LED. Another component that we'll be talking about is the switch. The switch is very important. I'm sure we are all familiar with switches. A switch is used to make a connection or to break a connection. So when a switch is turned on, we are just simply making the connection. We are closing the circuit. When you on the switch, it's closing the circuit and current flows. But when you turn off the switch, we are opening the circuit and current doesn't flow. This is the symbol of a switch. You can see the switch is open, and so when current flows, it's going to stop here. It tells us that this switch is off. But if this switch were to be closed, current flows. So these are different kinds of switches here that we'll be using in our projects. Another important component is the relay. The relay is also another kind of switch. It's an electromagnetic switch. It works on the principle of electromagnetic induction. It has 5 terminals. Well, there are different kinds of relays, but this one here is just the basic type of relay that we have. It has 5 terminals. Here, as you can see, this is the symbol of a relay. It has a coil. Terminal 1 and 2 are the terminals for the coil. Whenever a small electric current is sent into the coil, a magnetic field is generated. It is that magnetic field that turns on or turns off the switch at this other point. So once it gets energized, it changes its state. If it was closed before, normally closed before, it changes its state and becomes open. So that's just how it works. You send in small current. The small current creates a magnetic field. That magnetic field can drive high current in the other side. So if you put a load that requires high current, it can drive high current in the other side. We just need small current to turn it on or turn it off. So that is just it. It works like a normal switch, but this one using the principle of magnetism, electromagnetic induction. So that's the relay. Another component to be dealing with now is a transistor. Transistor is one of the major components in the field of electronics. In fact, majority of our gadgets we use today has so many transistors in them. These are electronic switches. They work automatically. In our computer system, we can have millions and billions of transistors in them. In our mobile phones, we have transistors in them. They work. There are several kinds of transistors. We have the bipolar junction transistor. This one here is called a BJT, bipolar junction transistor. We have other kinds of transistors. We have metal oxide semiconductor field effect transistors. As we progress, we will be introducing us to them. But this is just a basic transistor. It's an electronic switch. It can also act as a current amplifier, as we'll see later. All these components I've been talking about so far, if you want to have an in-depth knowledge, you can go and check up textbooks and read up. You understand how they work. But you know, this series is strictly for practical approach on electronic design, and so I'm just introducing us to these components so that we'll get familiar with them and you'll be able to build designs, electronic projects with them. That's all you need to know about the transistors. We have two types. We have the PNP and the NPN. Okay, let me just give a very simple illustration. The NPN is the most common type used. Whenever a current is sent into the base, it turns on the transistor. The transistor is turned on, working as a switch. But when current is not sent into the base, it is open. The transistor is off. But the PNP works the opposite way. When current is sent into it, it is open. That makes it off. When current is not sent into the base, it is on. That is closed. That makes it on. So the PNP is different from the NPN, but they all do the same way. As you progress in the study, you understand how to use them at every point in time. Okay, now another thing we'll be talking about, power sources. Power sources, we have two types of power sources. We have DC and AC power sources. DC here stands for direct current, telling us that the current that comes out of this source is just direct, it's in one direction. Direct current in one direction. I will give a better explanation in other slides, but just know that it's in one direction. And a good source of direct current is your battery. Your battery is a good source of direct current. So the current coming out from a battery is a direct current. It doesn't change. If it is 9 volts, it is 9 volts. If it is 6 volts, it is 6 volts. If the battery goes down to 3 volts, it is 3 volts at that point. So at every point in time, it is fixed, it is direct, it is one in one direction. But the other type of current, or the other type of power source we have, is the alternating current power source. That is the power source that we get from our wall socket. Anytime we plug a device into our wall socket, the current that flows into our device is called an alternating current. It changes its state, it alternates. I think the next slide will give us a better understanding of what I'm talking about. So you can see in our next slide, these are the symbols. These first three symbols are used to denote a DC power source. So this first one is a single cell DC, positive and negative. This other one represents a battery, positive and negative. This is also a voltage source. So these first three are DC. They represent, they are symbols for DC power sources. Anytime you see these symbols in your electric circuit diagram, just know we're talking about a direct current source. And a good example of direct current source, I've said before, is your battery. But this other symbol, you can see it has this alternating symbol here. It's an AC voltage source. Anytime you see this in your circuit, you know we are referring to an AC. So we are getting our power from the mains. When I say mains, I'm talking of your wall socket that is connected to your grid electricity. So there are two different kinds of power sources. This first one here, DC source, this is the symbol. As I said before, at any time t, at all times t, it is fixed. So if this was to be a 12 volt battery, it's 12 volt at that point. If it goes low to 9 volts, it is 9 volt at that point. But you can see the alternating source, it keeps varying from time to time. It goes in two directions, it goes forward and backward, positive and negative. You can see that, for example, if this were to be 220 volts AC alternating current, you can see that we can vary from 0 up to 220. So it keeps changing as it goes up. When it gets to maximum, it starts coming down, it keeps changing. From 220 it drops to 100 and something till it gets to 0 again. Then it goes through the negative half cycle. The negative points to it keeps rotating, going down rather, till the negative 220 and goes up. It could be any voltage. I just used 220 to illustrate. So these are power sources symbols and graphs. The next thing I'm talking about is the breadboard. Okay, now breadboard is very important in our electronic design. It's also referred to as prototyping board. I don't know why it was called a breadboard in the first place, but it is used for prototyping. Upon the breadboard, we will arrange our electronics components and power it, so we can do testing, we can analyze, we can find out the working operation of the circuit, build it, and the circuit comes to life on the breadboard. This is what we'll be using in our designs. In our future lessons, I may introduce us to soldering. You solder on the PCB, but you first of all prototype on your breadboard and ensure that everything is working fine before you solder, because once you solder, it may not be easy for you to unsolder again. It's best to be sure everything is working, all the components are working, your circuit is working fine on your breadboard before you solder on your printed circuit board. The breadboard has so many holes, and it's good to understand how to use the breadboard so that you don't damage your component. So in the next slide, I'll be showing us what the breadboard looks like. This is how the breadboard looks like. This is the bigger size breadboard. This line here is connected underground. Under the breadboard, there are some connections that have already been made. So you can see that there's a connection here underground horizontally from the beginning here to this point, and also from this point to the end we have connections on the ground for the two lines. See the other line. In fact, most times you use those lines for power rails, positive and negative for battery. You can see positive and negative. Most times they are used for power rails, but not all the times though. But most times it's just good practice to use them as power rails. So you can see that they are connected horizontally. At this point you can see that is an open circuit here. There's no connection. So if you want to make it connected from the beginning to the end, then you have to use a wire to link this place together so that it becomes connected from the beginning to the end. Same thing applies on the second line. And also under here, the same thing, we have the positive and negative terminals. It is connected horizontally at this point, horizontal connection. So please take note of that so that when you are designing you really understand. Then the other part, you can see these are the horizontal connections I showed you before. These holes are connected. So whatever components you put on this line, they are all connected to themselves. Whatever you put on the second line or this, either of these two, they are all connected to themselves. But now when we come to the other parts, the part labeled A to E, they are not connected horizontally, they are connected vertically. From A to E, every line is connected. You can see I used a red mark to show us they are all connected. Even these points I didn't mark red, they are all connected vertically. So you can see they are all connected vertically from beginning to the end. A to E, A to label E are all connected vertically. We have a gap here, there's no connection here. And most times this gap, as we proceed, you see the reason why these gaps are put here. When we want to place in our ICs, you will not want your terminals to connect to connect to themselves, your pins. I'll get to explain this as we proceed. And you can see that from point F to J, they are also connected vertically. The same thing. You can see the connections from beginning to the end, they are all connected vertically. So that's just how a breadboard works, because upon this breadboard we are going to build our electric circuits. When I give you a circuit, or when we want to design a circuit, is on the breadboard we design, then after which we can now transfer to a printed circuit board. Another thing you need to know, we have jumper wires. Well, I should have drawn the symbol, I didn't add the symbol. The symbol of jumper wire is just a straight line, just showing that okay, this is connected to this. So these are jumper wires that are used to make connections on your breadboard from one hole to another hole if you want to connect from one point to another. Another component, okay, now this is a multimeter. A multimeter is a tool you just have to have. It's used to, from the name multimeter, it does multi-functions. It's used to measure voltage, current, and resistance. We even have some advanced multimeters today that measure frequency. You can use to test capacitors and transistors. But basically, a multimeter measures voltage, current, and resistance. We have some meters that are just used to measure voltage. Those ones are called voltmeters. When you have a meter that measures only current, it's called an ammeter. A meter that measures only resistance is called an ohm meter. But this one is a multimeter. It measures all the quantities I've explained in our previous class. So I think this is the end of our lesson for today. If you enjoyed this video, kindly subscribe to this channel, like and share with your friends, and it will be a good platform for you guys to collaborate and work together and learn together. Click on the bell notification to be notified whenever I drop a new video. And if you have any comment to make, use the comment section below. Thank you. See you in the next lesson.